Hello, my name is Santiago Latorre, and today I will speak about calculus. Okay, now getting into derivatives, it's important to state that the first principle states how close it's the approach of the line to zero. For example, here we have the line, here is zero, and this formula, when the limits h is getting closer to zero, the line will be here, okay? Now we will move on to the derivatives of primitive functions. And the primitive functions are those such as cosine, sine, tangent, e, and ln x. For example, first we will start with the derivative of sine x. So here I put in the original function that sine x is the original function, and the f prime. F prime is also a way to call a derivative. When sine is the original function, the f prime, the derivative, will be cosine of x. Now we see cosine of x, and the derivative will be negative sine of x. After this, the other primitive function we can see is tangent of x, and the f prime of x will be 1 over cosine squared x. Now we will move on to e of x, and as we can see, f prime e to the x will remain the same unless, for example, here we have an example, where if e to the x is e to the 3x, the function will remain the same, but this number, the 3, will pass on to be forward of the e, and as a result, the result will be 3e to the 3x. The final function of a primitive function that we will see is ln x, and it consists of the same principles of e to the x, but instead the f prime would be 1 over x. So in the same way, if there's a number in front of ln, it will remain to be in front of x in another function. Continuing from the primitive functions, it's important to say that there are certain rules not only in primitive functions but on functions in general that must apply in order for derivatives to be correct. As we can see, the rule states that d over dx equals xn. It states that, for example, if we have a relationship with the chain and power rule, it would be that nx n minus 1 would be our f prime of x. Alright? Now, we will continue with an example. So, for example, if we have our function is y equals x minus 1 to the third power, our f prime or dy over dx, which would it equal to the 3 coming in front. So in this case it would be 3. We leave the function the same, so x minus 1, the inside the parentheses the same. We do 3 minus 1, so it would be 2, and the derivative of what's inside the parentheses and multiply that, but in this case it's only x, so it would be times 1. So dy over dx is equal to 3x minus 1 squared. The next rule that we will talk about is product rule. This is a rule that happens when products or multiplication occurs. Y equals u, a term, times another term. The rule says that dy over dx is equal to u times the derivative of v plus v times the derivative of u. Now, in order to understand this better, we will do an example where our function is y equals 5x squared ln 3x. First of all, we have to define what is u and what is v. In this case, 5x2 will be u and ln 3x will be v. Now, from this, we can now know what to do. So we put first dy dx, never forget to put it. We multiply, we said first. The first thing we do is place u as it is, so it's 5x squared, times the derivative of v, which is its ln x, it will be 1 over x. And then plus v itself, ln 3x, times the derivative of 5x squared, which would be, put this down to 10x. Okay, we did the whole function. Now, due to this, we have to simplify terms. For example, here we will put like terms. These two will cancel, 1x will cancel with an x. So the final result will be dy dx is equal to 5x plus the 10 always before 10x 3x, and that will be our derivative for the previous function using product rule. The next rule that we will use will be quotient. The rule quotient is for dividing terms. So for example, when u divided by v, the rule says that dy dx is equal to v times the derivative of u du over dx minus the u minus u times the derivative of v, and divide that by v squared. Now, an example that we will use today will be y equals 10x squared over sine 5x. Here is our function, and we also include all the primitive functions within the function to have a better understanding of their use in calculus. First of all, we have to label what is u and what is v, and as we saw before in the rule, we will label u as the top term and v is the bottom term. Now we move on to the derivative, so we put first dy over dx is equal to v first, so it would be sine 5x times the derivative of u, so it would be 20x, minus, as it is dividing, u 10x squared times the derivative of v, which in this case would be 5 cos 5x. And divide all of that by v squared, which is sine 5x squared, so it would be sine squared 5x. Now I will put the final result, which will be here down here, dy dx is equal to, simplifying like terms. So here we have the 20x, you can unite this to be 20x sine x minus 50x squared cos 5x, and that is our final answer for quotient rule example.